Hello, how are ya?
Oh, sorry about that. I was completely on mute. How are you doing?
I'm good. How are you?
Doing good.
Awesome.
Uh, all right, just trying to add everybody else in here.
You're good.
Okay. All right. Perfect. Oh, that's wrong email address. All right. Okay, there we go. Hoping everybody shows up. We'll see.
Perfect.
Uh, but how is your week going so far?
It's going good. Just so excited it's Thursday.
Oh, yeah. Can't wait until it's the weekend, eh?
Exactly.
Less stressful.
Uh-huh. Yeah, more
Yeah,
time to think of other things.
that's good.
All good.
Did everything work out at work or?
Yeah, I think so. Yeah, I'm fine. It's nothing with me. They have decided it's not my signature, so that's always good.
Yeah, that's fantastic. That's great.
Yeah, yeah.
Jeez.
So it
Frick.
it will be good.
Man, it's crazy when you hear about things like that happening, but when it happens to you, it's like a whole different ball game.
Mm-hmm.
Yeah.
Yeah, I really was freaked out for. I was like, that is just like nobody should ever sign my name. Like I'm not that important, Like
Yeah.
I have no clout.
Hey, dude, I don't even get the credit card. What's going on?
Exactly.
Oh, man, that's crazy.
Yeah.
All right. Well, I'm gonna see if I can try to invite them again.
Oh,
Ah, well. If not, then we may very well just start. It'll just be me and you. But
let's
I'm pretty
see.
sure.
Kim had sent something about an hour ago, but I couldn't get on to it. I don't know if you got that too.
Oh, Kim actually got back to you, eh?
Well, no, Kim sent out like a call like an hour ago at 5
Oh, I see.
when I was sitting here at work. But I
Okay.
popped on for a second, but I didn't. She wasn't there. I don't know.
Yeah, hopefully she's able to get in. I can
Mhm.
actually check my messages too. Maybe I'll see her there. All right. Okay. No, she didn't send anything to me yet.
Okay.
Yeah. I did send Clinton. I'll send Clinton one more time. All right. Okay, so I sent it to him. Yeah, I know that Stylen. He hasn't been able to make it because his son's unfortunately still in the hospital.
Oh, dang it.
Yeah,
That
I
is
hope
no.
everything's good. Jeez.
Yeah, yeah,
Man, our group has gone through a lot. I got in a car accident. Man, someone
exactly.
forged your signature, and then the first island is just, jeez.
Yeah, that is very true.
But we still make it through.
Yes, yes, we do.
All right. Well, I guess I'll wait maybe one more minute, and then we can probably just start.
Okay.
Yeah. Hopefully, join in soon. Yeah, I know for this one actually, it's interesting because when the exams come up, and for these practice quizzes, I
Uh-huh.
don't think I don't think you have to hand in anything regarding the meeting, which is weird.
Right. We just have to have the quiz together, but you don't just post the
Yeah,
video.
it's crazy.
Hmm.
All right. Well, I guess we shall start going.
Okay.
Awesome. I'm just going to open it up right now.
Perfect.
Okay. Awesome. So, okay. All right. So, question number 2. Given a 90% convenience interval of 45 and 105 for the mean heart rate, which of the following is the best interpretation of this convenience interval? 90% of all people have a heart rate between 45 and 105. We are 90% confident that the true mean heart rate is between 45 and 105. There is a 90% chance that the sample mean heart rate is between 45 and 105. There is a 90% chance that a true mean heart rate is between 45 and 105. Sorry, excuse me. I believe it would be the second one. We are 90% confident.
And it's not the true mean. Wait. It does say true mean in both of them. Okay. I just don't know why it's not the last one.
Sorry, say that again.
Is it why isn't it the last one? I believe it's the second one too, but just
that's a good question.
Okay.
Let me actually research it. I'm gonna actually double check.
Okay. I guess it's the difference between confident and chance.
Because I remember actually doing another test and like it didn't have the confident. Like it didn't say 90% confident. I remember there was another quiz. It just had like I think there was a 90% chance of the true mean heart rate is between 45. I think it had that one, and there's a whole bunch of other ones. Yeah, but it didn't have the confident part, which is weird. So I'm just gonna look through the textbook, see if I can find something. Okay. Loading. Hypotenuse, that's what I'm looking for. All right, so interval estimators. Yeah, okay, there we go. If you actually go to lesson number 10,
okay,
it actually gives you a bit of a description. It's just right below interpretation of convenience intervals. So it's the 4.3.
4.3.
Sorry, 4 points. Yeah, so, yep, 4.3.
Okay.
And then you just see like that in the green right there, the correct interpretation of 95 confidence interval is to say that we have 95% confident that the true mean lies within the lower and upper bounds of the convenience intervals.
Perfect.
Yeah, so I believe it would be that one. But that's a good question. I mean, why wouldn't it be the one below? I guess maybe it's because it says chance. That there is a 90% chance. I think that might be it.
Okay.
But it kind of makes sense a little bit when you say chance, but I guess confident is that it has to be basically in a level of significance that's 0.10.
Okay.
There we go. At least I'm hoping. I'm pretty sure that's right.
I'm pretty sure that's right too. Yeah.
Awesome.
Okay, so question 3. Here we go. Using the following information to answer the next 2 questions. Researchers at the University of Mississippi want to determine whether the research time in seconds to go, no-go of males is different than that of females. Researchers randomly select 20 females and 15 males to participate in the go, no-go simulations required for students to respond to a particular stimulus and not to respond to any other stimuli. The researchers decide to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence intervals would be reliable, they create a QQ plot to determine randomly sampled to see for both random samples to see if they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not?
Man,
No,
I actually
no.
haven't heard stimuli in a long time.
Yeah. Yep.
I actually had to research that question up.
Oh, did you?
Yeah, I was like, what the heck does that mean? Frick. That is so. Let's see. To determine.
So, because they did the QQ plot to see that they were both approximately normal.
Yeah.
So would it be yes, and then
I
because the third one?
Yeah, I believe you're right. Because even though that it may be 15 males and 20 females, they both are normal, right? So I think the distribution, yeah, I think you're right. I think it would be number 3.
Okay.
I think we're good
Perfect.
for that one then. Go bam.
Perfect.
Good job.
Thanks.
All right. All right, so I'll read the next one. Of the 4 types of confidence intervals, list below which is the appropriate for this experiment. Confidence interval for the mean of differences of using different samples. Confidence interval for you when standard deviation is unknown. I think that's population standard deviation is unknown. Confidence interval for the difference of means using an independent samples. Confidence interval for you when standard deviation for population is known. So which one for this experiment? All right.
I think it's the third one.
Yeah, I believe it would be the third
samples?
one too.
Okay.
Yeah, because they're basically, they're completely different samples. Mm-hmm. And they're just trying to figure out the mean for both of them, I believe.
Okay.
I believe so. All right.
Okay, number 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains a savings account balance of a random sample of 30 customers. A 95% confidence interval of the mean savings account balance of the bank customers is found to be that number and that number. Which of the following would produce a confidence interval with a smaller margin of error than 95% confidence?
Okay.
I don't think it's the smaller number because that would make it not a good sample size, right?
Yeah,
like first
I believe out, so.
And then the higher the percentage, isn't it, the more the spread it is?
Yep, that's right.
So then it would, and then, so how about the third one? Because if you do more people, then it should be a better in-depth, smaller number, or closer to get smaller margin of error.
Yeah, so I believe it would be number 4. It would be obtain the balance of 90 bank customers rather than 30.
Sweet.
There we go. Awesome. Because I think actually, if you calculate that up, I'm going to do that real quick. Squared, say 90. Yeah, that's 2.6. And I'm just putting random numbers right in right now. Yeah. So 90. So that's times by 1.69.
Hi, Clinton.
Hey.
Hey, what's up, Clinton?
Sorry about that.
No worries, man. But anyways, I think you're right, Wendy. I think it's the 4th one.
Okay.
Awesome. All right, my friend. We are actually just on we just finished number 5. So we're moving on to question number 6.
Do you want to tell me the answers real quick? I'll put it on the
Yeah, of course. Yeah, not a problem. Yeah. Sure. So for question number 2, me and Wendy, we put for so question number 2, we are 90% confident that the true mean of heart rate is between 45 and 105. And then for question number 3, we put yes, the distribution of the mean of each sample is normal, since the data we have determined to be normal. So that would be the third one in question 3. And then question number 4 would be the third one, which is confidence interval for the difference of means using independent samples.
So that's the fourth one?
So number 4 would be number 3. So confidence interval for the different means using independent samples. And then, here we go. And then for number 5, it'd be the last one. So obtain the balance of 90 bank customers rather than 30.
Okay.
There we go. All right. And Wendy, would you like to read the next one?
Yes.
Awesome.
A factory makes a propeller drive shaft for a ship. The engineer at the factory needs an estimation of the true mean length of the shafts. Anyways, the random selected four drive shafts made at the factory measured their lengths and found that their sample mean to be 1,000 millimeters mm. The lengths are known to follow the normal distribution, whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Input your answers in the margin of error, low bound and upper bound.
Awesome. All right. So this one we'd use the equation. I'm going to do it quick. Yeah, so it'd be 2 divided by, hold up, not 2. Oh yeah, so it'd be 4. So 4 would actually be the sample. I mean, sorry, yeah, it'd be the sample. So it'd be standard deviation divided by squared 4 times by 1.96, which would give us 1.96 for the margin of error. Is that what you guys got, or?
To be quite honest with you, I am still looking for the equation. It's like the x is plus or minus?
No worries.
No?
I think actually, yeah, you're on the right track.
The square root of n is at the bottom. That's all I remember.
Yeah, so it would be that one right there. If you go all the way to the bottom, yeah, it would be m equals z times by standard deviation divided by sample mean. I mean the sample square rooted. So it would be right at the bottom of lesson number 10.
Lesson 10. Okay.
Yep.
There we go.
Yes. Awesome. And this one actually, it's a bit tricky because they don't actually give you the sample, like not as a number. They put the quantity assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts. So that would be the sample, would be 4. So just for n. You guys probably already knew that, but hey, I find it a little complicated sometimes.
You're good.
Awesome. Yeah, so that would be the equation. So what you do is you do 2, which is the standard deviation, divided by square root of 4, which will give you 1, times by 1.96. Because that would be the convenience interval.
1.96. And then So is the
sorry, go for it.
no. The margin of error is 1.96, and then so is the upper bound, is that plus 2?
Yeah, so
I mean the lower bound minus 2.
so the lower bound would be -2, so it would be 1,000 millimeters. Take away 1.96, so that would give you 998.04, and then I think it's saying, let's see, is it telling us to round it up? Yeah, it's rounded to 3 decimal places, so then you just put another 0.
Okay.
And then for the other one, for question 8, yeah, just be the opposite. It would just be adding it. So then you should get 1001.960. Yeah. Do you guys get those two, or?
I haven't got that far.
At least I believe that would be basically the upper and the lower.
Yeah, you're right.
Yeah, awesome. Good.
On that.
I'm happy I get some clarification. That's great.
Yeah.
All right.
Thanks for reminding me. Eventually I would have got there.
Oh yeah, it's just a matter of finding the equation. That's pretty much it. Just find both these equations and you're good to go.
Yeah.
All right. So question number 9. I can read that one for you guys. I guess you got that too, eh, Clinton? For those two, or?
Just continue. I'm kind of a little lost here.
Yeah. Oh, no worries, man. If you want us to go over it, that's not a problem too, bro.
I haven't got it, so you're good.
Yeah. Okay. Hey, well, man, if you ever just let me know, and then we can definitely talk to it for sure as a group. We hook you up. That's for sure. Awesome. All right. So question number 9: to access the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighted a total of n times, and the mean of the weights is computed. Suppose the scale reads a normal distributed with an unknown mean and a standard deviation of 0.01 grams. How large should n be so that 95 convenience interval for u has a margin of error of 0.0001? So this is another equation that actually should be in lesson 10 too. And it'll be the last one. So right at the bottom there in the pink, if you look in the pink tab right there, it's just the last equation right there. So n equals z score times by standard deviation divided by m, and then all that is squared. So I actually have to do that right now. All right. Okay. Okay. Let's look at the Z score. Okay. Z score is 1.696. And you guys already know how to find the Z scores for the level of significance, right?
From the
Oh, sorry. Go for it, Wendy.
Oh, just from the applet.
Yeah, that's.
Or there's a graph in chapter 10.
Yeah, that's how I do it too. I use the graph rather than the applet. I'm not too sure. Maybe I'm using the applet incorrectly, but like every time I put it in for like 95, so 0.95, I think it gives you a different number.
Oh.
So yeah, that's pretty much. I kind of use that graph more often. That's for sure.
That makes sense.
0.01.
38416.
We're all getting text messages. Bam. All right, I've got to check that. Yep. Okay. There we go. All right.
I also got 38416.
Yep, that's what I got too. Awesome. So we are all good for that one. All right, so question number 10. Would you like to read that? Awesome. Yeah. Thanks, Cliff.
Okay, the mean area of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. Propagate null and alternate hypothesis. I'm thinking it's option D.
Option B.
D.
Oh, D, yeah. Yeah, option D, yeah. Okay. Yeah, I believe you're right. Because it's saying that it is actually, it'd be less, right? Smaller.
Yeah.
Yeah, that's right. Yep, kabam. We're good. All right. Question 11, I actually kind of looked over. It looks pretty simple. All right, so question number 11. In a statistical test of hypotenuse, we say that we reject the null hypotenuse with a level of significance if the p-value is less than the level of significance. I believe it would be the second one.
Yeah, I think so too.
Awesome.
Yeah.
All right. Question number 12. Would you like to read that, Wendy?
You got it. A group of statistics students want to determine if a student is in some apartment buildings get better grades than students in other apartment buildings. They collect GPA from the anonymous random sample of size 15 from each sample size 15 from each of the 4 different apartment buildings. The data for each apartment building are best shaped with no outliers, and the sample variants are nearly equal. Can you use a NOVA hypotenuse test to answer these questions?
I think it's option C.
Yeah, I believe that would be right too.
Yeah.
Yeah. Just because everything is, because everything is, all the variances are equal, right?
Right.
Yeah. All right. Awesome. Question. Okay. Oh, yeah, you go for it, Clint. Awesome.
Question 13. Medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Okay, I'm going to skip a little bit. It's too big.
No worries.
Keep in mind that new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has, I think, committed a type 1 error. It would be A.
Yeah, I believe you'd be right, because she initially was trying to prove that the hypotenuse for the first one was wrong, but then she realized that actually the new experiment she did, and there was no difference.
That's right.
Yeah, so I think it would be type 1 error for sure.
Any words, Wendy?
Oh, what was that, man?
Perfect. Sounds great.
Okay.
Oh, legit.
Well, when you
Awesome.
don't talk, I kind of feel like we're just like ignoring you and just going forward.
Oh no, move forward. I actually was looking at this going, I have no idea, but sure. That sounds
Okay.
great to me.
Okay.
All right.
All right. 14, I guess.
Sure. Oh, I'll read it for you guys. 14. If the level of significance is made very small, thereby then making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? Type 1 error is very small. What happens to the... I believe, actually, yeah, I think I read this in the textbook. I think it would be the first one.
I think that's what I read too. Where it increases the probability of committing a type 2 error.
Yeah, because like I think for type 1 error is like when it's very significantly, like if it's bigger, and then for type 2 it's like when if it's bigger, then yeah, I believe it's that one.
Perfect. I'm assuming this is in chapter 4, the last one before the test.
The last one. Okay.
Yeah.
Not the last one. I'm
That
getting
one.
there.
It's
That one I didn't read.
No worries. Hey, there's tons of stuff that I still have to review over.
Yeah.
Man, I'm gonna be up pretty late today, tomorrow, maybe a little bit on Saturday. We'll see. Well, not late on Saturday because that's when we have to do the exam. But that is for sure.
Mm-hmm.
But if you want to, actually, I know that it is. If you want to see where it is, I remember seeing it. I'm gonna actually see where exactly it states that. All right, so it's not that one. Or if you guys already know where it is, then that's awesome.
I don't.
Yeah, I found it.
Okay.
So it's actually in it's actually lesson 9, and if you just look down, type 1 and type 2 errors. So just right there, it'll give you an explanation. So it says whenever we reject the null, we say that is a type 1 error. Okay, sorry. Whenever we reject a true null hypotenuse, so for that one, it was a true, like when we were talking about beforehand, it was a true null hypotenuse. So we say that it's a type 1 error we commit. Assuming that the null hypotenuse is true, the level of significance is the probability of getting a value of a statistic that is extreme enough that the null hypotenuse will be rejected. In other words, the level of significance is the probability of committing a type 1 error. So she was kind of trying to reject the null hypotenuse, but she ended up actually rejecting her. So what she did is that there was an experiment beforehand that she was doing, and the null hypotenuse was true. So she did an experiment with another thing to see if it was basically anything different in regards to the experiment. And basically, it wasn't whatsoever. So she rejected hers, and then in turn became a type 1 error. I hoping that makes sense.
It does now. It's coming back. I was like, I thought that was last unit. Nope, it's this unit. We got it.
Awesome. There you go. But that's all the information, and you're good to go.
Perfect. I'm good. I got it.
Awesome. Okay. So question 15.
Okay. Here we go. Ready? The nicotine contained in cigarettes of a certain brand is normally distributed, with the mean in milligrams. That's the mean. Anyways, and the known standard deviation of 0.17. The brand advertises that the mean nicotine contained in its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give us a sample mean of 1.53. Is this evidence that is the mean nicotine contained is actually higher than advertised? To answer this question, test the hypothesis, this one, at the level significant of 1 or 0.05.
All right. So I believe that, I think So since the sample mean it's greater than, right? I think that the p-value would actually be less because it's different from the actual, it's different than the hypotenuse. So I think that you would reject the null hypotenuse. So it'd be, I think it would be the last one. I mean, correct me if I'm wrong. I mean, I think it would be that one because it's greater than it, right? So I think that the p-value would be significantly less, and if it was the level significance of 0.05. I mean, I believe it would be that way.
Do we reject the null or the null? Or do you fail to reject the null? Like, can you reject the null? Does that make sense?
Yeah.
Or is it always the alternate one that you reject or not reject?
Yeah, I think it would be reject. Actually, I think you I actually figured this out. If you want to, you can actually manually enter in the values into the one sample t-test of means.
Okay.
So you can actually do that. So right now we got the null hypotenuse, which is so it's 1.5, which is the null hypotenuse. So 1.5. And we're looking for greater than, is that correct?
Yeah.
Yes, higher. Yeah, okay. So now what we can do is actually, we can go to the mean, and the mean so the mean, sample mean, is 1.53. And I think this will make more sense for us when we do it this way. 1.5. Standard deviation is 0.17. And then the number, random sample of 100, right? Yeah.
Mm-hmm.
Awesome. On this. Maybe I entered it incorrectly. So what did you guys get for that when you entered it in?
For the p-value or for the?
For the p-value.
I have 1.5.
1.5. Yeah, I must have done it wrong. Maybe it doesn't work that way. Let me check again. Anyways, I believe it would be the last one. I believe it would be that one.
I think it is reject null too.
Yeah. I mean, I think I might have to mess around with this a little bit more to try to see if I can actually utilize it. But I guess that would be my guess.
Okay.
All right.
I'm good with it.
All right. Awesome. All right. I think we can definitely come back to that one again. I guess I'll read the next one. You would be like, okay, so you would like to look at the mean number of hours worked for wages per week by male students and female students. We'd like a random sample of 100 of each group and test if those means are different. What is the correct statistical procedure? So one sample z-test, independent sample t-test, ANOVA, a paired sample t-test, or one sample t-test. So I think it would be independent sample t-test. Because you're looking at the difference of the means, right? So you're not necessarily pairing them up and trying to determine which one is more and which one is less.
I think you're right. And it says the random sample of 100 of each group, not like in a household.
Yep, that's right. All right. Awesome. Okay. Question 17. But I guess everybody's good for that one then, eh?
Yeah.
Mm-hmm.
Yeah, awesome. So, Clinton, would you like to read the next one, Mom, man?
Yeah, I can read 17.
Awesome.
An educator is interested in academic achievements by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same house. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? I think it would be dependent sampling.
Yeah, I believe that you'd be right, man. I think dependent
the
sampling.
last one.
The last one is what I think too.
Yeah.
Yeah, I believe it would be that one too. Well, it does say pair in there, so you know, maybe that will help out. So I think that's probably. I think you guys are right. I think it would be the fourth one. All right. Question number 18. A soil. Oh, did you want to go for it? Sorry, when do you go for it?
Nope, I'll let you. No, you got this. I'll let you.
All right. A soil scientist collects a random soil sample from a field and measures the dissolved organic carbon, mg / liters, level of each sample. The measurements are recorded in dissolved organic carbon. The researcher would like to construct a 95 convenience interval for the mean dissolved organic carbon level in the field. Of the 4 types of convenience intervals listed below, which one is appropriate for the situation? Wow, this one is... So I think it would be the first one.
Yeah.
Because I believe soil samples of field measured. What do you guys think? Because this one I'm actually not completely sure about.
Oh, 2027? Gosh, it'd be so old.
I think you're right. Because I don't think it's more than, like, I don't think it's an independent one. Like, I think it's one field.
Yeah.
Samples from the field.
And it says soil samples, right? It's not a complete interval for the population. So it's just like a mean sample, I believe.
Mm-hmm.
Yeah. So I think that it would be that, just because it's not a complete, like you wouldn't be able to find the complete standard deviation for everything, because it's just a collection of the samples. I mean, if that makes sense. I'm not completely.
Well, that makes sense to me.
Okay,
Yeah.
so I think it would be the first one. What do you think, Clinton? Oh,
The confidence interval for the first one?
yeah.
That's what I
I'm trying to wrap my head around it. Why it would be that way, though? I'm pretty sure it's that, but I'm trying to understand that. Yeah. I guess it would. Yeah, I guess it would just. That's the only explanation. I guess. I mean, if you guys have any ideas, just let her go. But I guess we can just leave 18 for that for now.
Okay.
And we can move on to the next one. I just have to put in the data. All right. So next one. I'll go for it. Which of the following is the 90% convenience interval for this analyst? Input your answers for the margin of error, lower bound and upper bound. Determine the margin of error for this 95% convenience interval. Okay. And this would just be a one sample T, I believe.
Mm-hmm.
All right. So what did you guys get for the margin of error? So I got 2.025.
Yeah, that's what I got.
Yeah, awesome. And then upper bound and lower bound are pretty simple. You just kind of look at them. So upper bound, I got 11.168.
Is that lower bound?
Yep, as lower bound, yeah.
Okay. And upper bound was 15.217.
Yep, that's right.
Okay.
Kabam. Nice. All right. So when did you get those ones or?
Yeah.
Yep.
Yeah. We're good.
Awesome. You're just ahead of the game. Sweet. Okay.
I was just typing, man. I couldn't talk and type at that moment.
No, not a problem. All right. So I guess, Clinton, would you like to read the next one, my man?
Yeah.
Awesome.
Okay, a random sample of Hummers for sale in Los Angeles and New York were taken from listing at cars.com. Data are recorded in this Excel sheet. We want to know if there is a difference in mean listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. Of the 4 types of confidence interval listed below, which one is the most appropriate for the situation?
So for this one, I think it would be the third one. Confidence interval for the difference of mean using independent samples. You guys get that one too?
Mhm.
Just because I believe when it's saying create of 95's convenience interval for the true differences of mean, listing prices between two cities. So they're looking for two differences of means, right? And independent samples because I don't think one affects the other. They're just trying to look at the different ones.
Yeah, I see that too. I think it's option C.
Yeah, legit. Awesome. Okay.
The next one says calculate the 95% confidence interval for the true difference of means list prices between the Hummers from LA and New York, and put your answer for the lower and upper bound.
All right. Okay. Los Angeles is the first one. New York is the second group. Okay. One thing I did realize too, guys, is like when you're doing the paired sample t-test, and it's different from this one. But one thing I did realize is that when you're using that one, there actually is a formula inside of the differences. So if you, I know that when in the textbook it says like, you know, you take away the first variable from the second variable. But if you kind of don't use the formula, sometimes the numbers actually won't calculate properly. I realized that. I was like, dang it. Well, great.
All of this is in the exam this week, is it?
Oh, I'm sorry. What was that, my friend?
All of this in the exam for this weekend?
So I believe, yeah. So I believe that it'll be all of this. Plus, it's going to be all of Unit 2. So everything that we learned from day 1, all the way from from like right now.
From day 1, so even what was in exam 1 is going to be in it.
Yeah, I believe so. I think that it might just be like you just like, you know, like differences from chronological, from like quantitative. I mean, yeah, just pretty much everything. Yeah, just a firm grasp of everything.
Just, I don't think he said he would question on Unit 1, but like you have to know that the U looking thing means mu or means mean and stuff like that. Just
Yeah.
that, not that it's gonna go back and ask questions.
Oh, okay. So yeah.
I mean, I'm hoping, you know, that's gonna be okay like that. If it's like a lot of stuff, it's gonna be quite intense.
Mm-hmm.
That's for sure.
Okay, for the lower bound, I got negative 423.238.
Yep, that's what I got too.
And the upper bound is 5417.336.
Yeah. All right.
Perfect.
Wait, what did you get for lower bound again?
Negative 423. Sorry, negative 423.238.
Okay. Yeah.
Yeah, and then for the second one, it was just actually you probably already got it. Just 5,417.336.
I got that.
Awesome. Okay, moving on. All right. So many students have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random for 3 groups. A control with no jumping, a low jump group, The jump height was 30 centimeters, and a high jump group, 60 centimeters. After 8 weeks of 10 jumps per day, 5 per week, the bone density of the rats was measured. The data are recorded in the Excel sheet. And a question. Research would like to determine if the mean levels of the bone density are different between 3 different groups of rats listed above. I use the level significance of 0.05. And what is the correct hypotenuse test for the situation? So I think 20. Yeah, that's right. That's what I got to. Because it's for 2 or more groups. All right, so I just have to do the Excel sheet. I love when you copy and paste it, it says you can't do it. Happens to me all the time.
Yeah.
All right, it's test statistic. So what did you guys get for the test statistic?
I got 7.978.
Yeah, that's what I got too. And then the p-value I got 0.002.
Yep.
Awesome. All right. Moving on. Are you good with that, Wendy, or?
I am.
Awesome. Okay.
Not very convincing.
I am indeed.
Okay.
100% confidence level over here.
Nice. Cavale. Love the confidence.
Yeah.
Alright. I guess I can read. Yeah.
Yep.
I'll read for you guys. I know that we're trying to alternate. Actually, if you, yeah, I guess we'll go in the circle. Do you guys know what turn it is again? Or?
I have no idea. Do you want me to go?
Okay. Sure.
Okay, which of the following best expresses the of this test? Use a level of significance 0.05.
Okay. So I think it would be 1, 2, 3, 4. I think it would be the fourth one.
The fourth one.
Yeah. Just because the p-value is 0.001. So it's actually less than the significance level, making it it is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from one of the mean bone density of at least one of the other groups.
Okay. Do we never? Is it always just one, and not all?
Yeah.
Like in option A. Okay.
Yeah, because if you look in the textbook, because I remember that, if you go to
all would it might not always be all. So that makes sense that it would just be one.
Yeah, that's right. Yeah.
Okay. Perfect.
All right. Man, that would suck. I thought I just X'd out of the quiz. It's like, great,
Oh.
nothing's saved.
Oh.
Great, I should probably save everything now. All right. Wow, where are we right now? I lost myself.
We're on
Jeez.
29, and it's not my turn to read.
All right. Sweet. I mean, you don't have to read all that if you don't want to. We can all read through it on our own. It's up to you guys. All right. Actually, you know what? I'll go for it. How about this? I'll take it on.
You got it.
It's massive, so I'll do it. All right. Pressure of supply and demand act directly on the prices for airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If the seats on the flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there was a difference in mean costs of airline ticket purchases. 90 days in advance of a scheduled flight compared with a ticket purchase only 14 days in advance. Data was collected on the costs of one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket price one-way flights from Heathrow, the various destinations in Europe, was recorded for each scheduling flight 90 days in advance, and then again 14 days in advance. The data are recorded in Excel sheet direct flight costs. Perform a hypotenuse test to determine if there's a difference in the mean costs of the non-stopping flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of 0.10 for the next 4 questions. Do 14 days, take away 90 days for analysts. Well, that actually gave us a hint. So this actually, what is the correct hypotenuse test for this situation? So I believe it would be dependent sample test. A dependent sample test.
I believe you're right.
Yeah.
Back on number 27, when I told you I was 100% confident, I think it might be 0.002. Do we need to round up on that P-score?
Oh, okay. All right. I trust you. I'll put that in.
Okay.
Awesome.
I really was going off the study guide. I printed it out, and that one wasn't an option as 001. So I went back and looked.
So great. And then the one thing I was thinking that we would kind of, if you didn't look at it, like the one that says, you know how we did the margin of error and we did 0.40? That would have sucked if we didn't put a 0.
Mm-hmm.
That's right. All right. So continuing on with the question, calculate the test statistic. So yeah, let's put everything in. Yeah, so for this one, I know that there is a formula in Excel. I've deleted them before. It didn't give the right answer. So the one thing to keep in mind, because if you look at differences, there actually is an equation. I mean, a formula in the Excel sheet.
In the box.
Yeah. I'm just like, great. If I put that in the exam, that'd be fun. All right. Okay. So for the t-test, what did you guys get for the t-test?
1.685.
Yep, that's what I got too. And then I got for the p-value is 0.096.
Right.
Awesome. All right, next question. Which of the following best expresses the conclusion of the test using a level of significance 0.10? So there is sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance. There is sufficient evidence to conclude that there's a significant difference in the mean costs of tickets purchased 14 days in advance compared to in advance. So I think it would be the second one. Because since it's 0.096, there's enough evidence to kind of reject the null. And then therefore there's sufficient evidence to conclude there's a difference in the mean cost. You guys think? What do you guys think?
Yeah.
Yep.
So
Awesome.
B, right?
Yeah, it would be B, yeah. Yeah. Well, I believe that is the test, guys.
Can you go over 6, 7, and 8 real quick?
Yeah, for sure. Not a problem.
Even 9.
6.
I mean, just the answers.
Yep, not a problem, my friend. So the answer was for 6, it was 1.96.
Okay.
And then for question 7, it was 998.040. And then for 8, it was 1,000, so it's 1,001.960.
Okay. And 9 was 38416.
So, yep. So 9 was 38416.
Okay. Perfect.
Yeah. I mean, if you want to I can actually we can even talk about how to figure it out. But if you're familiar with that, man, it's all good.
Yeah, I got it after I was a little behind when we started off.
Oh yeah,
So
yeah, that's
I was
right.
doing that as we're going, so I just wanted to double check the answer.
Yeah, no worries, man. Not a problem. Yep, I'd be the same way. You'd be like, wait a second, what equation? What's going on? But I guess that's it, guys. Otherwise, if you guys want to talk about anything else, like regarding the homework at all, actually, I did have one question. Maybe you guys might be able to help me out with it. So it actually was, if I go back to the homework assignment, for lesson 13, like I was trying to understand one question, but I wasn't completely sure. So it says, does the confidence interval you compute does the confidence interval you compute in question 6 contain the value 0? If so, what does this suggest about the mean prices of cars that are listed for sale by a dealer versus those sold for a sale by a private individual? So that question, when I was reading that one, I know that so it says what does it mean if your confidence interval is equal up to 0? But the one question I was thinking is how do you know that it's equal up to 0? Your intervals. So that was a tough question. Yeah, did not understand that whatsoever. But what I'm thinking is. Oh, go for it. Sorry, go for it.
Well, I didn't know if the upper and lower bounds were the same number. So the mean was always the same number. So that's why the confidence interval would be 0, because there was no difference.
Yeah, exactly. I mean, in pertaining between. Oh, sorry. Repeat that again. Sorry.
Oh, that there was no difference between the upper and lower bound number, so that the mean between the interval, so that the means were all the same, so there was no difference in the mean.
Yeah, that makes sense. Because what I was thinking is that for the intervals, when you're thinking of a graph, right? So you have both the x-axis and the y-axis. Mm-hmm. So you have basically one going vertically, one going horizontally. What I was thinking is that when it was saying for this question, it's just if it equals up to 0, because you have the two intervals, right? And one interval is positive, which is on one side, one is negative on the other side. So you have this graph and you have the probability applet, right? You know how you have that probability graph? You have proper terminology for it was Wow, what is it again? It's the bubble. Anyways, it's that big, massive hill. But anyways, with that, what I was thinking is that the 0 is in the middle. So if you had two intervals that were positive, then the interval wouldn't be equal to 0. Does that make sense? Because there's no 0 in between. So that's what I was thinking. I don't know if that's right. I don't know if that's true or not, but I was trying to get some clarification from you guys. Yeah.
I'm not 100% sure on that either. I didn't do that part of the homework, so I don't know.
Well, no worries. I mean, I don't think that's going to be on the test. I mean, obviously, when you guys are doing it, I believe that it'll just be like you can select A, B, or C, and then you'll probably get it right. But yeah, for the life of me, I couldn't understand that. Jeez. Hey, but anyways, I guess that's it for the quiz. Did you guys have any other questions at all, or you're just going to try to grind it through and try to study, just like me?
Pretty much.
Just going to live on a prayer and just take it eventually.
Yeah, that's right.
I will study, take notes, take them with me. He did show a cool thing. Did you guys watch his screencast this week by chance?
Yeah, I did actually, yeah.
I like that from that table-y thing that you could fill out.
Yeah, that's right. Yeah, I want to fill that one out too. And I think it'll make the exam. And he said that we could use that, right?
Mm-hmm. He said you could use that plus your 1 page of notes.
Dude, that's awesome.
Yeah.
Way cool.
Yeah. So.
Yeah.
Best of luck. I have got to go to my bowling league now.
Nice. That's awesome.
Thursday night. Thursday night.
Get some strikes. That's fantastic.
Will do. Okay. We will see you guys on Tuesday.
Yep. Hey, take care, guys.
See ya.
Bye.
All right. But Clinton, you didn't have any other questions at all, eh, man?
No, I think I'm good.
Yeah,
just gonna
awesome.
start studying for the exam, and I think I'm gonna go take it.
Yeah, that's me too, man. Gonna pray I do good.
Right. Good luck.
Hey, good luck, my friend. We'll see you next week.
Talk to you later.